Welcome back to another session of construction planning. Students, till now in the session of in the lecture series of construction planning, we have learned about typical methods or conventional methods of project planning, that was bar chart and milestone chart. Then after, we have started learning about network methods. Now in network methods, we have learned about what is network. Network was a flow diagram consisting of activities and events. So we have learned about the definition of activity and definition of events. After that, we have learned about types of activities and types of events. There were 4 types of activities and 5 types of events. And at last, we have learned about the rules for drawing up the network. Yes, that we have learned that to draw a network which is consisting of arrow and circle. Circles are representing events or nodes, while arrows are representing activities. So, to draw a network consisting of circles and arrows, we need to follow certain rules. So that was up to the last session. So if you are not aware about any of this, kindly go back to the previous session, watch the video, and then come back to this session. So today in this session, we are going to learn, yes, we are going to start with the numerical parts. The first numericals, the numerical based on drawing the network, in which we are going to see 2 categories. The first category is numericals based on data given by words. That means entire sum will be drafted in number of words in lines, and we have to draw the network based on that data. And the second is data given on the basis of predecessor and or successor activity. Predecessor and successor. Predecessor, that means before the activity. If Q before B, A before B, and successor B after A. So such before and after conditions will be given for the activities, and we have to interpret them and we have to draw the network. So today we are going to see 2 categories of sum for drawing the network only. So let us start. Alright, so before starting any numerical, here are the few points to be noted, 2 points to be remembered while drawing entire network. That network must be started from one single initial node. There should be one single initial node at the starting of the network. Second is, there should be only one final node in the network, and that node should have only incoming arrows. Third one was, number of activities equals to number of arrows. Fourth one was, no looping or backward path is possible in the network diagram. And the last was, a dummy activity is represented to maintain the logic or to reduce the duplication of the activity. So these are the points which we need to keep in mind while drawing the network. So let us start with our question number 1. So here is our first question for drawing the network, as the question says that drawing the network for the following data. So let me read the data for you. So the first data given to you is activity A is the first activity of the network. Then activity B, C and D can be started parallelly after the activity A has been completed. Then activity E follows activity B. Then activity F and G follows activity C and D respectively. That means F follows C and G follows D. That is our fourth data. And the last data given to you is activity H is the last activity of the network whose predecessor activities are E, F and G. So this is our first category of numericals, that says data in words. Here as you can see, all the data is in the lines. So this is our first category. Now to draw the network from such data, we need to focus on each line at a time. We'll read one data at a time and we will draw the network for the same. So starting with the first data, A is the starting activity. So let us draw the network. So here is the first activity of our network. As we know that network should be starting from one single initial node. Then the arrow should represent the activity. Here the first activity is A. Now students, listen me carefully. We will write the name of the activity above the arrow. We will write the name of the activity above the arrow. And as you can see in that question, that activity A is the only activity in starting. So we can complete it by the head event. So here I have represented the first activity by reading the first data of the question. That activity A is the first activity. Now come back to the question and let us read the second data. Now, the second data says that activity B, C and D can be started parallelly after the completion of the activity A. So, let us represent that scenario in network. So, here is the graphical representation or the representation in the network for the data number 2, that was B, C, D can be started parallelly after the completion of activity A. So as you can see, I have represented B, C and D. Three activities are starting parallelly. That is our second data. Now let us read the third data. So the third data is activity E follows B. Activity E follows B. That means from activity B, there will be a following activity named activity E. So let us draw an activity from the head event of the B. So here, as you can see, this is our network in the network representation of data number 4, that activity E follow B. Now come back to the data. So the next data is activity F and G follows activity C and D respectively. So activity F will follow C and activity G follows D. Let us represent it onto our network. So as you can see over here, now the activity F will be from will coming out from activity C, and activity G will be coming out from the activity D. So now we have three activities, activity E, F and G. So that is our data number 4 or 5, I guess 5. Now let us read the last data. So the last data is activity H is the last activity of the network and whose precedence activity are E, F and G. So from E, F and G, H is coming out. Let us represent the scenario in the network. So as you can see, from E, F and G, activity H is coming out. So here I have represented H 3 times. But it is possible? No, definitely no. Because as per the rule of our network drawing, we cannot represent any activity more than once. That is our rule. So I cannot represent this arrow for H 3 times. But the data was saying that from E, F and G, H is coming out. So now focus on the drawing, students. Focus on the drawing. What we can do, is it possible to merge the end points of E, F and G? Check that. Is it possible to merge the events, the head events, the end points of E, F and G? Yes, it is possible. And from that combine, we can now drag or we can now represent the H activity coming out. Let us see this. So now, as you can see over here, I have merged the end head event for all of these three activity E, F and G, and now H is coming out of it. So this is the correct representation of our network. Here our question number 1 ends. Students, one thing which I like to mention over here is you have to create a network directly like this. You don't have to show step-by-step composition. you have to only draw the final output. This step-by-step procedure is only for your better understanding. In examination, you have to directly draw the entire network in, at one go. I hope you are understanding me. And the second point is, in these circles are representing events. So in these events, you have to do numbering. And to do numbering, there is a rule, Dr. Fulkerson's rule. Now, let me, that's very basic and easy rule. What you have to do is what that scientist has told in his rule, that from left to right, we are drawing the network from left to right in our page. So from left to right, which circle is coming first, give it number 1. So it is obvious that tail event of A will be numbered as 1. Now see in the network, how many circles are there? Only one circle is next circle is only 1, so that is number 2. After that, there are 3 circles in parallel sequence, so you can number it 3, 4, 5. Then again there is one circle 6, and the last one will be 7. So numbering will be look like this. So here is the numbering numbering of the events, that 1, 2, 3, 4, 5, 6 and 7. From left to right, those circles are coming first will be numbered sequentially. Easy and simple. So that is our question number 1. Let us look at another question. So here is our question number 2. Draw the network for the following data. Here the data consisting of 4 lines. Let us read. Activity A is the starting activity and proceeds activity B and C. That is our first data. Second data is activity D depends on activity B. Activity D depends on activity B. The next is activity E follows or depends on activity C. And the last data is that activity F is the last activity of the network and can be started after activity D and E are completed. So this is the data of 4 lines for which we have to draw the network. So the first data is that activity A is the first activity, proceeds activity B and C. So let us start with this. So as discussed, that activity A is the first activity and proceeds B and C. So this is our first represented activity. Now proceeds B and C. So let us draw that. So this is how we'll represent the activity B and C. So this is our first data. Activity A is the starting activity, proceeds activity B and C. Now let's come back to the question and read the further line. So the next data is activity D depending on activity B. Activity D depending on activity B. Now this word depending means follows. So activity D is coming out from the activity B. So let us draw that. So this is how activity D is being represented, coming out from activity B. Let us read the question again. Activity E follows activity C. The next data is activity E follows activity C. So let us represent that into network. So as we have done for the B, we have done for the C. That activity E follows C. Follows means coming out from the C. So I have represented E coming out from the C. Now let us read the last data and complete the network. So the last data is activity F is the last activity and can only be started after D and E are completed. That means F should be started only after D and E are completed. So let us draw this. So here I have represented F coming out of the D and F coming out of E. But again, as you know, this is not correct because this is against of our rule. One activity cannot be performed twice. So now again we have to check that what if I could combine the endpoints of activity D and E. Check that. Again, I'm repeating it again. Focus on the words. what if I can combine both the events or not? Yes, we can combine the events. So let us combine that event and then we can represent the f. Let us see that scenario. So this is the correct representation of the network, that I've combined the head events of D and E and then I've represented the F. Now again, numbering. Let us see the numbering of the network. So here is the network numbering, that 1, 2, then two circles are coming parallelly, so 3 and 4, then 5, and last is 6. So this is how numbering should be done. That is rule of Fulkerson's rule, that from left to right, which circle is coming first, you have to number it sequentially. So there was only one circle at start, so 1. After that, in sequence, there was only one circle, so 2. After that, there were 2 circles, so 3 and 4 parallelly, then again 5 and 6. So that is how we'll do the numbering. So I hope we are clear about the first category, that reading from the lines. Now the second category is data given on the basis of predecessor and successor activity. So let us see a question first. So here is the question given in tabular format, for which we need to draw the network diagram. So as you can see over here, there are 2 columns in the table given as the data. The first column is of activity and the second column is of predecessor activity. Predecessor, that means before the activity happens. So activities are from A to K, A, B, C, D up to K. Now the predecessor are given as, for activity A, there is no predecessor. For activity B, there is no predecessor. For activity C, the predecessor is activity A. For activity D, predecessor is B. For activity E, predecessor is A. For activity F, predecessor is B. Now, for activity G, predecessor are C and D. For activity H, predecessor are G and F. For activity I, predecessor is E. For activity J, predecessor are H and I. And for the last activity K, predecessor is J. So this is the entire table which is given to us, and by using this data we need to draw the network diagram. So here, students, when the data is given into the predecessor and successor form in the tabular format, we will read 2 lines at a time. 2 lines at a time. So I'm talking about here activity A and B. Now activity A and B does not have any predecessor. Predecessor means before that activity. So for before A and B, there is no activity. That means activity A and B are the starting activity. So let us represent that into network diagram. So here I have represented activity A and activity B. Is it correct? No, this is not a correct representation. Why? Because as per the rule number 1 of network diagram, there should be only one single initial node. So here is the correct representation of it. So this is how we can represent that A and B are the first activity, can be started parallelly. So this is the representation of first 2 data. Now let us come back to the question and read the further data. So here, students, now we will focus on predecessor. For those activities whose predecessor are common, are easy to represent. So as you can see over here, activity C and E are having predecessor A, and activity D and F are having predecessor as B. So first we will represent C and E from activity A, and then we will represent D and F from activity B. Let us draw the network. So this is how we will represent it, that from activity A, C and E are coming out, and from activity B, D and F are coming out. So here students, in tabular format, we are taking two data at a time. If it is convenient, you can go one by one, but if it is convenient to you, you can take two data at a time. Moving forward, let us come back to the question and read another data. Now, activity G is having predecessor activity C and D. That means before activity G happens, activity G is coming out from C and D. Let us represent that. So here, as per the data, C is the predecessor of G. So I've taken out G from C, as well as I've taken out G from the D. So there are two G activities, and that cannot happen in a network diagram. So again, what we need to do is we need to check that are C and D endpoints of C and D can be merged. Check that endpoints of C and D can be merged. Yes, they can be merged. So we will merge the endpoints of C and D, and then we will draw the activity G. Let us see that. So this is the correct representation of what we was discussing in the previous slide, that we need to merge the endpoints of activity C and D, and then we can represent the activity G. I hope we are clear about it. Let us come back to the question and read another data. The next data is activity H having predecessor activity G and F. Activity H is having predecessor activity G and F. Let us draw that. So again, I could represent the activity G and F having H separately, but now you know the logic that when the activity is having two predecessor, those activities of those endpoints should be combined, and then the next activity should be commenced. So I've combined the endpoints of activity G and F, and then I've represented the activity H. I hope we are clear up to this point. Now, let's come back to the data. Next is activity I having predecessor E and activity J having predecessor H and I. Activity I having predecessor E and activity J having predecessor H and I. Let us draw this. So as you can see in the network diagram, activity E, from that I is coming out. Now the next was from activity H and I, activity J is coming out. Now H is that below over there, I is from coming from the E. Now out of that, J is coming there. So we need to merge the endpoints of H and I, and then we have to represent the J. Let us do that. So this is the representation of H and I, and then out of that J is coming out. Let us read the last data. So the last data is activity K having predecessor activity J. So this is the last representation of the last activity, and this is our completion of the network. Now students, here I would like to mention another point, that shape of the network does not matter. When you are drawing up a network, the shape of the network does not matter. You have to only focus on the rules, that starting should be one event, ending should be one event, there should be only left to right path, there should be no reverse or looping of the path. So these kind of rules you have to remember. You don't have to manage the shape of the network, that it should be looking decent and nice. You are not here to draw a nice network. You are here to draw the correct network. Remember that. Now, as far as the numberings are concerned, try to give the numbering by yourself, and the answer will be looking like this. So here are the actual network with the numbering from 1 to 9. Now, count the number of activities and count the number of arrows. They will match, and that is your verification, that number of activities are always equals to number of arrows. So I hope we are clear up to this point. So this is it. That was all about in today's session. In case of any query or doubt, you can always contact me on my mail or my number. Thank you.